26th of September, a fire at the Hyeondai Premium Outlet Daejeon broke out. This disaster caused 8 casualties. And a few days ago, a fire at SK CNC data center caused inconvenience to the whole nation. There were no direct casualty of life, but delayed response made the situation worse. Hello, we are Team 5. Today, we will propose robots that are to be put into danger sites. In our presentation, I will discuss first, problem presented, and second, challenges and difficulties, and lastly, resolution and experimental design. At the beginning, we introduced some recent cases of disasters. Like this, disasters are closely related to our lives. It can cause inconvenience and confusion in our daily lives. Using artificial intelligent robots, we look forward to minimizing damage in a great disaster such as a conflagration scene, collapse site, and radioactive spill site. Actually, there are robots which put out fire, but it is not fully practical and there are clear limitations. These robots can only perform simple tasks directed by a person. Let's consider a situation where a disaster takes place in a large building such as a department store. The structure of the building is very complex. There are potential blind spots everywhere. As a matter of fact, it is almost impossible for humans to check every possible places. To solve this problem, we additionally need highly developed intelligent robots. In case of fire, even after fire goes out, the toxic gas remains and becomes a big threat to the firefighters. Humans can lose consciousness very quickly in such cases. Also, the air becomes cloudy and disturbs the rescue operation. So, it is very important to preempt the scene situation in real time. This information is essential for saving lives. If all these processes are done autonomously, we will be able to produce mass results with less effort. Our model should be able to solve this problem. Ideal solution must be able to form a route to move along, detect and distinguish risk factors and rescue signals, and then take necessary action. Also, it should be able to create a map containing all the above factors. Forming a route is important, since route is essential for all operations for human and additional robot entry. The size of the route should be measured in order to decide if human navigation is possible. Detecting and distinguishing risk factors and rescue signals are important for efficient data collection. In order to maintain utility, even when multiple robots are deployed simultaneously, each unit must have intelligence to cooperate and do the task. To express damage expansion, immediate action will be taken at necessary times. For example, combustion can be necessary to save emergency patients buried under rubber. Of course, the safety should be checked beforehand by other robots. Last but not least, the data collected by the intelligence should be given in an intuitive method for humans in charge to comprehend the whole situation. The most appropriate method is to create a map containing the route, the signals, and all the other information. We will create a simplified prototype of the ideal model. We aim to create an intelligence for robots to move along the given path and gather information. Also, It will be able to take simple action according to gathered information. The information will be shown intuitively on a map for time, and we found a reference about the SLAM algorithm, SLAM algorithm, to help visualize the map. And this is the end of our presentation. Thank you for listening.